All right, welcome to this next part where we're going to be picking up where we left off last time, and we're going to texture the kettlebell that we just modeled. So we're going to go through what's called a procedural texturing approach, which means we're going to create materials from scratch, textures from scratch. And then I'll show you some other methods where you can use existing textures that are out there online to then create a similar texture to what we see in our reference imagery. So to start, let's just pull up our reference imagery and let's have a look here at what we want to accomplish. For the scope of this tutorial, I basically just want to make this rough black metal texture, and then I want to create this decal on the front. We're not going to go into this embossed texture or engraved texture in this particular tutorial, but I think we're going to have room for an additional texturing tutorial that's maybe a little bit more advanced. Right now, I want to get you a really great foundation in texturing in Blender. So before we apply textures to something, we need what are called UVs. I've talked about this very briefly, but basically a UV map is how we decide to unwrap a 3D surface so that it lays flat on a 2D image, because we need to be able to use 2D images on our 3D object. So as it stands right now, our kettlebell doesn't have a texture and it doesn't have UVs. So to start with adding a material, sometimes I use the word texture and material interchangeably. Just know that a material is the properties of a surface. It has textures within it. When I'm talking about textures, I'm talking about specific images or procedural setups that drive the properties of that material. So I really shouldn't say let's add a texture, let's go ahead and add a material. To add a material, we just need to go to the material properties down here, and then we could just simply click new material. Let's go ahead and call this kettlebell underscore mat for material. Whatever you want to call it is just fine. Now, we opened up our shader editor in the last video to set up our HDRI. If you weren't with us for that part, let's just show you what to do here. To create a new editor type or a new area, just right click a border and let's go to vertical split. And then on the editor type dropdown, we can change this to the shader editor. And this window has an N panel and a T panel, just like our 3D viewport. We can collapse those. And we have our shader editor for this kettlebell. If you come down on this shader type, we can also change the world shader properties where we have our HDRI set up. But for now, let's keep it at object. And I'm going to collapse this. We'll start to get into that in just a minute. For now, in our material properties here, we have a lot of the same settings as we do in our shader editor. We have our base color, which is just the color of the surface. We have metallic. A value of 0 is non-metal or dielectric, and a value of 1 is perfectly metallic. Then we have our roughness. A value of 1 is perfectly rough. A value of 0 is perfectly glossy. As you can see here, it just got real shiny. Let's put that back at like 0.5. Then we have our IOR. This stands for index of refraction. Every physical surface in the real world has a specific index of refraction. Like this glass cup has a different index of refraction to my desktop, my wood desktop. So everything has its own value. This default value of 1.5 works for a lot of different materials. If you want to get scientific and really exact, you can Google the index of refraction for a particular element. So like maybe aluminum or something, you could look that up. Generally speaking, I just leave this at 1.5. Like I said, it works for most materials. Then we have an alpha value, just fading the transparency of our object here or our surface. Under diffuse, we have a separate diffuse roughness. This isn't something we're going to change with this particular material, but just so you know, it does have a separate roughness setting for that. Then we have subsurface settings. Now, subsurface scattering, the best way I can describe it is light penetrating into a surface. So if you think about like candle wax, for example, that's a classic one. If we increase the weight of our subsurface scattering right here, then we start to see this subsurface effect slightly in our material. You can start to see it more if I were to increase the scale of how far that light penetrates into the surface. And now this is looking very, very waxy. So that's subsurface scattering. We also have a vector here, which is just a series of 3 numbers. That's all a vector is. In this case, we have RGB. The red value is higher than the green and the blue, so that subsurface scattering, the subsurface level, has a little bit more of a red tint. If I set this to something like 90, it would be even more red. If I set this to 0 and really increase the green, then we would have more of a green tint on the inside. By default, it's kind of like this waxy, fleshy look. Then we have our scale. I changed that to something higher so we could see into the surface more. And we have something called anisotropy, something like that. Not 100% sure on how to pronounce this one. I'm going to get into this on our next setting, specularity, but just know that subsurface scattering has its own anisotropy. So let's go ahead and turn off our subsurface scattering. Now we've covered that. And under specularity, we have a few things. First, we have our distribution method, GGX or multi-scatter GGX. I've never changed this. There's probably a reason that someone smarter than me knows out there on why you would change this. Go ahead and leave a comment. But I've always left it at multi-scatter GGX. I don't really see a big difference. Then we have our IOR level. This is basically our specular level, the level of our specular reflections on our surface. If we set this to 0, you can see all the specular reflections disappeared. If we set it to 1, they're particularly strong. By default, it's 0.5. As I understand it, that's physically correct. You can cheat this back and forth depending on the material, but I would just leave it at 0.5 for most cases. Now we have a specular tint, where we could actually change the tint of our specular reflection. As you can see, I just did there. This is another one. Most of the time, I'm just leaving it at the default value. Now, we have the anisotropic I said I would cover. The best way to show this is maybe to turn on the metallic and turn down the roughness. Now, if I turn this up, you can kind of see the difference between off and on. We also have anisotropic rotation. The best way I can describe this is it's kind of like brushed stainless steel. That's a good example of this out in the wild. This is something that you can turn up basically if you're making a surface like brushed stainless steel. If not, that's pretty much going to stay off for me. Now let's bring up the roughness, bring back down the metalness, and let's keep moving here. So next we have transmission. This is basically like transmissive glass, for example. That would be totally transmissive with a lower roughness value and no color there. That's how we would make that glass material that I'm holding. So let's go back. Let's add that blue back in there and let's reduce our transmission, turn it back off. And then we're getting into coat, also known as clear coat. Now this one's really cool. If we turn up the weight of this, it gives us basically a separate layer of glossiness. So good example of this is if you have like a waxed floor, you have the glossiness for the floor, and then you have the glossiness for the wax that's polished and sitting on top of that. So you might have like kind of rough underneath, and then the clear coat is on top of that and it's glossy on top of that. Another good example is like a car. If a car has been waxed, it would have this property. You also get this in actually monitors or TV screens. A lot of the times they have like a rough layer underneath and then some kind of a coat on the top that makes it more glossy. So that is clear coat. It also has its own IOR and its own tint if we wanted to change that tint of the clear coat on top there. But for now, let's turn off clear coat. Move on to sheen, which is kind of like fuzziness is the best way I could describe it. my sweater here as the light hits my shoulder at this glancing angle, not the direct straight on angle, but where you're getting more of a glancing angle, you get a bit of sheen here, which is kind of just like fuzziness. So sheen is used a lot on like fabric, like denim jeans have a really obvious sheen a lot of the times. Sheen has its own roughness as well, and it has its own tint, but we'll go ahead and turn that one off because we've covered that. Next is emission. This has a strength value and a color value. Not much to that one. You can plug in different maps to tell the surface where it should be emissive and what color it should be, but we'll get into maps in just a minute. For now, let's turn the emission strength off. And finally, we have thin film. This is basically like a thin, oftentimes oily film that's on the surface of an object. You can think of like bubbles or like an oil puddle on the ground. If I get rid of the saturation so we can see this clearly, let's increase the thickness of our thin film. Try to get this to where we can see what's going on. And let's just increase the IOR to something quite high. Then you could start to see the thin film makes like this. If we had a map plugged in here for varying thickness on our thin film, then you would get kind of like the rainbow effect. Similar to, like I said, like a bubble or an oil spill, or even in nature, you see it on like beetle skin or a lot of insects. They have like this thin film property. So yeah, pretty cool. Also a little bit niche for very specific materials. So those are the basics of materials. Before we get into actual textures, let's try to get this overall material as close to the kettlebell metal as we can. So this color is not bad. We might go a little bit darker, maybe increase the roughness. And this actually isn't metallic, I don't believe, because I think there's a coating on the top of it. I could be wrong, but I'm going to leave metallic down for this one. And yeah, that's about as far as we can go if we're working just from our surface properties over here, or our material properties over here. Now, we can take this a lot further if we get into our shader editor. So I'm going to go ahead and shrink that back down so we could see our shader editor. Save my blend file. And now let's actually get into some textures. So when you open up your shader editor, by default, a new material will have what's called a principled BSDF and a material output. A principled shader, all it is it's a collection of attributes that a lot of different surfaces share. So this isn't the only shader that you can use, but this is really useful because you could use this one shader for all kinds of different surfaces. And you'll notice we have little input nodes for each of these attributes. These are all the attributes we've already gone through, but now we have little input nodes where we can input like noise textures or image textures. These are all very, very useful. So let's start with our procedural texturing approach, just by adding our first basic procedural noise. So just go ahead and hit Shift A and search for noise texture. And if we plug that into the base color, you could see we have this colorful noise. Or if we just use the factor, we have this black and white noise. And we could play with these values like increasing the scale, increasing the detail, maybe the distortion. We get some interesting effects there. And this is kind of the very, very basic building blocks of a procedural texture. We could also drop down if we search for something called a ramp. We could use a color ramp and just drop that in between those two, which will interrupt the flow and add that. This could be used to like clamp down on the whites or clamp up on the blacks, for example, or to change this to a different color. Color ramp is a very, very useful node. We can increase the scale here. Maybe we can increase the lowest value here so it's not as much contrast. And yeah, we can start to build some procedural layering in here. We could use another noise texture or the same noise texture for our roughness. and we could drop down another color ramp if we wanted to tweak that value as well. Now, notice that there's a difference between this yellow dot and this gray dot. This yellow dot is letting us know it takes a color channel, which means it'll take RGB values. This gray dot is letting us know all it needs here is non-color data, or just a value from black to white. So it's fine that we're using this color ramp and this noise texture for this roughness. But just know there's a difference between an input that takes color data and an input that takes non-color data, and it's trying to let us know by this color coding system. And we'll get down to this other vector down here in just a minute when we get to talking about something called normals. But right now, just know that on the roughness input, the darker it is, the more glossy it is, and the lighter the value is, the more rough it is. So if I clamped down on this roughness, you could see that this pure white is starting to be very rough, while this darker, this pure black, is being very glossy. So if I put those right up against each other, we would have a high contrast of very glossy to very rough, which isn't really the look we're going for. I would say we're more middle ground with not as much contrast, maybe something like this. Now this is a very basic procedural texture. I'll get into some more advanced procedural texturing, but just starting to give you a taste for some of the tools that you have at your disposal. So that's it for the basic noise texture node. Now if you hit Shift A, you can go through all kinds of different inputs and textures that we have here. We have our noise texture under textures. We also have an image texture where we can use actual images, which is what I'm going to get into now. So let's just delete everything we've created so far. Let's keep the principled BSDF shader. Let's save our file. And then I'm going to open up my web browser to a website called textures.com. So if we go to textures.com, no surprise, on textures.com, we have a lot of different textures. Now, this is a paid website. You would have to subscribe to it to get access, but if you're going to be creating in 3D very frequently, if you're getting paid for it, I definitely recommend subscribing to this site. There are also some other ones. I don't personally subscribe to Polygon, but this is another one that has a lot of textures in it. And there's a free resource called Polyhaven, which we used in our last video for HDRIs, but if you just go to polyhaven.com, they also have free textures. So you could go through here and try to find some maps that work for whatever you're creating. Now, when I say texture maps, I'm talking about a collection of images that define the properties of a particular texture. So if I go to textures.com, we can search for metal, for example, and let's find a metal that is roughly a good starting point for our kettlebell metal. I feel like, let's see, pitted rust is pretty good. We can change some of the attributes there to get rid of the rusty color, but I feel like that's a pretty good starting point. So we could take a look at pitted rust here, and then we could start to download the various maps. So each of these maps, as they're called, are responsible for identifying the surface attributes of a different part of the surface. So example, we have albedo here, which is the color. It's similar to base color. Then we have height, which is kind of like the bumpiness, but it's bumpiness that breaks up the surface of your model. We're not going to get into this one for this tutorial, but we also have normal maps, which is more performant than a height map. And a normal map is just going to identify some of the smaller details that don't necessarily break up the silhouette, but kind of like your micro bumpiness details. Then we have roughness, which we've already looked at. It's the difference between glossy, which are the darker colors, and perfectly rough, which are the lighter values. Then we have a metallic map, which the black areas or the darker areas will be non-metal or what's called dielectric, and then the lighter areas will be metallic. So just looking around here to see if I have an example of metal. I have this clamp here, and obviously some of that clamp is metallic, and the surface of metal is going to behave differently than something that's non-metal or dielectric. So the rubber grip here would be dielectric, the metal here would be metallic, and every surface, the idea is every surface kind of has a range. Actually, a true surface is either metallic or non-metallic, but we may have a little bit of blending between that if we had like dust or dirt in between. So we have metallic maps that help us identify which parts of the surface are metallic and which parts are not. And then we have an ambient occlusion map, which is kind of like fake shadows within the albedo texture, which I'll show you as well. So for right now, let's just go ahead and download each of these maps. You can also find something similar on Polyhaven. If you want to follow along for free, you can find some kind of a metal texture that's comparable. It's going to be exactly the same process as I teach you about these maps. So go ahead and download those. I found that 2K is going to be plenty for our purposes. And once you have those downloaded, there is a really, really easy way to set these up in Blender with our Node Wrangler add-on enabled, which we enabled in the last video. All you have to do is hit Control-Shift-T, and that will open up our principled texture setup. So now all you have to do is navigate to wherever your maps were. So we have our ambient occlusion, metalness, roughness, normal, and albedo. I'm not going to use the height image. Just grab everything all at once and then just click this principled texture setup button. And just like that, it will set up all of our different textures. Now, we do have a big problem. If we zoom in here, we could see we have some strange stretching here on parts of the mesh. And that's because we haven't done what's called a UV unwrap. So every object in 3D needs to have seams identified on that object, basically where we cut the object so that it could be laid out flat. So take my jar here, for example. If I were to lay this out flat on the table surface, I would need to place a seam all the way down here and maybe around the bottom so that we could unfold this and lay it out flat on my table here. Now, obviously I can't do that with this glass, but that's just the general idea. What we need to do is identify some areas to cut into this to be able to lay it flat on our UV map or on our 2D image. So let's go to solid view, edit mode, and let's start to identify some seams. I'm going to go to edge select mode, hold down Alt, and I'm going to start by selecting some edge loops here. Now I'm just kind of thinking through where I would cut this open if I wanted it to lay flat in the real world. So I'm going to grab another one here. I'm going to press C for circle select and hold down my middle mouse button to deselect some of those areas. We want to select as little as possible because seams can be visible in the actual texture. So it's kind of, well, it's a seam. It's where the texture doesn't line up with itself anymore. So I'm just identifying a few areas. There's no right or wrong answers here. You can always test it out and see what kind of results you get. So let's say we wanted those seams. Let's hit U for the UV menu, and we can go to Mark Seam. Then if we split this area by right-clicking and go to Horizontal Split, let's change this editor type on the bottom to our UV editor. Now, if we select everything, we don't have UVs yet, but now that we have the seams, we can press U again. Let's go to Unwrap, and there's some different unwrapping algorithms. You can test out each one. There's angle-based, conformal, or minimum stretch. I'm just going to go with minimum stretch to try that one out. And you could see our surface of the kettlebell is unwrapped right here on the 2D space. However, we might still have some stretching. A good way to check is you can go ahead and look at your texture. So I just went to Material Preview, and that looks pretty good actually. Another thing you could do is you can add a texture just with Shift A. Let's add an image texture, and we can do a new texture, and we can actually generate what's called a UV grid. So let's go ahead and set this generate type to UV grid, press new image, and let's plug this into the base color. So now we have this checker grid, which is much easier to tell if we have stretching. And sure enough, where this is trying to meet at the bottom here and at the front, we have some stretching. So to mitigate that, I'm just going to add 2 more seams right here, just on each side. And let's press U and mark seam. And that won't unwrap for us. We'll have to select everything again, go to U, unwrap, and let's do minimum stretch again. And that's looking pretty good. I don't see any obvious stretching, so we can get rid of our little UV grid here, move it off to the side, and let's use our texture again, which is actually this base color. Let's plug that in. There we go. If we go to render view, that's actually pretty good as a starting point. Now, if we wanted to increase the frequency of this texture or these texture maps, that is where we would use what's called our mapping, which are those 2 nodes that we already added in the previous video, our texture coordinate, which is telling us to use our UV map, and our mapping node, which is where we can change the rotation and the scale frequency and everything of our texture. Now you'll notice the principled texture setup automatically connected these to every single map. So if we change this in one place, it'll change the scale or the mapping of all of our different textures. So if I wanted to increase the frequency, it was a value of 1, where it's just going to have 1 image for the whole map. If we change that to 3, it'll be 3 times smaller details, or 3 times the frequency. So a value of 3, we could see we get much smaller details right there, and I think that's looking pretty good. Now, one thing I should cover is when the principled texture set up our material automatically with that Control-Shift-T. What it did was it changed the color space of some of our images by default. Remember how I was talking about this yellow dot versus the gray dot versus the purple dot? Different inputs, different surface inputs are looking for different kinds of maps. When I say maps, that's basically interchangeable with the word texture, all right? So we have all these different textures. Base color is the yellow dot, and that's letting us know that it's expecting a color image. In this case, our color space is just set to the default, which is sRGB. It's just using red, green, and blue, and this is actually appropriate for our base color, so we didn't need to change that. When you input a metallic map, if you didn't use the principled shader setup with our Control-Shift-T setup, if you just dragged an image into here, by default, this will be set to our sRGB. However, this metallic, since it's going to this little gray dot, is an example of something that's non-color data. So instead of using red, green, blue, it's just using values from 0 to 1. So in order for this metallic map to show up properly on our texture, we would need to just go ahead and change the color space to non-color data. This is getting into some advanced stuff like linear color workflow and things like that. Now, those are things that we'll cover when we get into the rendering module. But for now, just know that some images are color data, like base color, and pretty much all the other textures or images, like roughness and metallic, anything that's black and white, it's basically going to take this non-color data. A normal map is also a linear image on the back end. What that means, all you have to remember is a normal map is also, or should also be set to non-color data. And it'll be obvious if you get this wrong. If this normal map is set to sRGB, for example, we get this really strange artifacts on our image. That just means you forgot to set this to non-color data. So you can simply just click on this right here and type in N, and it'll set that to non-color data. Another thing we need for our normal map, that's kind of loud. Another thing we need for our normal map is, you'll notice we're going from a color, a yellow slot here, to a vector or a purple slot here. What we need, if we just plug that straight into normal, you'll also see some obvious issues. What you usually need to add, and what our principled texture setup set up automatically for us, is you need to search here for a normal map, and you just add that in between your normal image and the normal input, and that'll convert from the color to the normal information. You also get this handy slider where you can change the strength of your normal map if we really wanted to crank that, but we could just leave that at a value of 1. So that's how you set up existing textures, with the exception of our ambient occlusion. We still haven't figured out how to get that in there. All we need to do there is add down what's called a mix color node. Drop that right here. So our base color is going into the A slot, and our ambient occlusion is going into the B slot. And all the ambient occlusion is it's a black and white image that's multiplied over the top of our base color. So instead of a mix shader here, we can change this to multiply, and now that's basically just multiplying over the top. In this particular texture, it's not making a huge difference having that ambient occlusion off or on, but now you know how to set up AO or ambient occlusion if you have it for a different texture. All right, we are rolling right along here. One thing I want to change is I want to get rid of the color in the divots here. So we could just simply search for a hue saturation value node. We could drop that down right here, and we could just decrease the saturation. Or we could use, if I just alt drag that, alt left click drag, it'll disconnect it and we can delete it. We can also use the color ramp that we used earlier, and that'll automatically make it black and white. And this has the added benefit of maybe decreasing the light areas so there's less contrast. If you ever want to solo a node to see what it's contributing to the material, just Control Shift and click on that node, and that'll let you isolate that particular node so you can really see what the effect is on your overall shader. When you're done soloing that, you can just Control Shift click on your principled shader and it'll go back to normal. So that's pretty good. We've gone over some basic procedural materials, very basic. Then we've gone over setting up existing maps from something like textures.com or Polyhaven. The last piece of the puzzle is getting that decal on here. Now, I do want to cover more advanced procedural texturing with you, but it's just not in the cards for this particular video. That's going to be something we'll cover in future videos, or you can go to patreon.com/RileyB3D, where I have a lot of tutorials where I texture using an advanced procedural texturing tool in Blender called, now I'm drawing a blank, it's called Fluent Materializer. You can look it up on Gumroad, go purchase it. It's also on Blender Market. On Gumroad, I think the creator gets a bit of a larger cut than if you pay through Blender Market, just if you want to be aware of that. But yeah, I go over much more advanced procedural texturing in those. It's not really the place for this particular tutorial. What we're going to do here is just going to take it through the finish line by adding a decal. Now, adding decals in Blender requires us to get into our first outside third-party add-on that I'm going to recommend. And that add-on is called Decal Master. So if you just search for Decal Master, it'll take you to this Blender Market listing. And this is a really, really convenient Blender plugin. I'm going to show you how to use it. Now, the benefit of this, you could technically do decals just in vanilla Blender, in unchanged Blender, but it's a very convoluted workflow. So this is just one of those cases where I have to suggest Decal Master if you intend to texture in something like Blender, which we'll try to keep it in Blender as much as I can, although I do have tutorials where we get into substance and that, all that good stuff. But for now, go ahead, if you want to follow along, I recommend purchasing Decal Master, and I'm going to show you how to use it. It's very convenient. What we're going to do is in our reference imagery, if we pull up Pure Ref again, we can actually steal this little decal right here. You could, of course, create your own decal in something like Photoshop or whatever, but we could just take a screenshot and steal this. On Windows, that's just Shift Windows S to take a screenshot. We could take a screenshot of that. Now, I've already taken one and I've already saved one out for the purpose of this tutorial. I open it up in Photoshop and I actually got rid of the background, so it's just the letters. That's just a really quick and dirty way to kind of steal a texture, and we can use that as our decal. So I've saved that on my disk, and after you've installed Decal Master, let me just show you how to install it. So to install any add-on in Blender, just go to Edit and Preferences. A lot of add-ons will come in the extension library, so you could start by searching for it there. Decal Master, it's not there. The extension library is mostly for free add-ons, ones that can come with Blender. Decal Master is a paid add-on, so we just need to go to Add-ons, and then you would just go here, this little drop down, and say Install from Disk. Now, as soon as you install it, you just select the zip folder and it'll install the whole thing automatically. I've already installed mine, as you can see here. After you install it, just turn it on by checking this checkbox, and then you can read up if you want about this particular add-on, and there's sometimes add-on preferences here. So go ahead and save preferences after you've installed it, and when you have, let me just shrink this area down here. Let's save this, go to Solid View. If we open up our N panel, that's our right-hand panel, we get this new tab called Decal Master. So once we have that, we can go ahead and do Add Decal Setup. So let's select our object first, Add Decal Setup, and that has added some fun little nodes here, actually just one node, that we don't really have to think about. This is just to get Decal Master working. So just so you're aware, it did add a node to our shader editor, but now all we have to do is click on this button called Start Projecting, and what that'll do is it'll place us in our scene, looking at our object and placing our little decal here. Now, we can position this decal just by navigating around the scene. We can also press S to scale up, or we can hit R to rotate. You might notice this is not our decal image. This is just a placeholder one. In order to get our decal, you can just look on the left here. It says Decal Import is the F key. So let's just press F. That'll open up a file browser. From here, let's see, I think I saved it in my downloads. Import decal, and there you go. We can scale it up. We can rotate it. We can kind of position this. Once we have positioning that we're happy with, we could just press spacebar to project that decal, and then escape to exit out of there. And now, if we go to our render view, sure enough, we have that decal projected automatically. And that's kind of the basics of texturing your first texture in Blender. Now, we've used some pre-built texture maps from textures.com or from Polyhaven, whatever you decided to use. If you wanted to get into more advanced procedural texturing, that is something that I can cover on my Patreon that I've already covered in videos, or we can come back for a more in-depth texturing video in this series. But for now, go ahead and do a rendering. Let's go to Solid View. Always go to Solid View before you render, because you don't want your viewport rendering taking up your VRAM at the same time as your render engine. So then go ahead and just press F12. Let's fire off another rendering, and this is where we're going to leave it for this video. Thanks for watching. If you've made it to this fourth video, hopefully you had a chance to review the first 3 videos and take a look at our process up to this point. If you've never touched Blender before, I tried to make this series starting at video number 1 as if you've never used 3D software, and slowly progressing to this point. Where do we go from here? Well, we can get into some animating, some rigging. We can get into some more advanced modeling, advanced textures. Let me know what you want to see next in the comments if there's something particular you're struggling with, or always go to patreon.com/RileyB3D. If you join my Patreon, you get access to my exclusive private Discord server where you can get on, you can ask me questions, you can send me your blend files, and I will give you hands-on help as I have with many people on there already. So thanks for watching. Thanks for sticking through this series. It's tough to get to this point if you've never used 3D software before, but I'm proud of you. You've made it here, and I'll see you in the next video.